All right. As we get ready to take our Unit 1 test, here's a video that might come in handy as you study up. So just going to run through the sample test key, give fairly thorough explanations, but probably I'll try to be as thorough as I can, but as always, pause the video and if you need to slow it down and re-watch certain parts. But here we go. 1 and 2. I want you to find a positive angle less than 360 degrees or 2 pi that is coterminal with each of the following. So you got to know what coterminal means, or at least how to get through problems like this. So with 700 degrees, we're looking for something coterminal with 700 that is positive but less than 360. So to do that, all you really got to do in this case is subtract 360 until you get to, because every time you subtract or add 360, you're going to get to something coterminal. But in this case, we want to be subtracting 360, and that's all it takes because we get to 340, and that fits the criteria. So 340 degrees. For negative 26 pi over 5, probably the first thing you want to do is convert that to degrees because it's just easier to work with degrees. How do we do that? Well, here we can just replace the pi with 180 because they're equivalent. So just plug in 180 for pi, and it turns out, and 26 times that divided by 5, so we got negative 936 degrees. So here it's like we have to add 360, but then it turns out we have to add 360 again, and then actually add 360 again until we get to an angle that fits the directions. And so 144 degrees, final answer. Number 2 wants us to just evaluate these 3 problems. And so for angles such as 270, this is going to turn out to be 90. And for 180, for angles such as these are like the really, really, really nice angles. Remember, they're called the quadrantal angles? But these are really nice because for angles that are basically like on an axis, you can just get those XY coordinates really, really easy. And those coordinates would be on the unit circle, okay? And so what are the unit circle coordinates at 270? Hopefully you can pretty quick get 0, -1. And if it's on the unit circle, that would mean the radius is 1, okay? So once we have an x value, a y value, and an r value, we can just use the definition of cosine as x over r, and so that would mean x 0 over, so it would be like 0 over 1, which is 0. So you for the test, you're basically dead in the water if you don't know all of these definitions, okay? If you just don't know that the cosine is x over r, and the tangent, for example, is y over x, and the secant is the flip of the cosine, and therefore r over, if you don't know all 6, or maybe I can put it in terms of, if you don't know the big 3 and which ones you flip to get the other 3, you are in big, 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 big trouble. You're going to lose a lot of points, okay? So you definitely need to know, for example, the cosine is x over r. Okay, so the tangent, what are the unit circle coordinates, which means r equals 1, for 90? Wouldn't that be 0, 1? And since tangent is the y coordinate divided by the x coordinate, y divided by x, we got 1 divided by 0, which doesn't exist because you can't divide by 0. So you got to know that. If If you end up with something like 1 over 0, it does not exist. It's not like here where it was 0 over 1, that's just 0, but 1 over 0 does not exist. Over here, for 180 degrees, what are the coordinates for that angle at 180? You should be able to come up with -1 comma 0 on your own with no help. Okay, so you got to know that. And so r would again be 1 because that point is on the unit circle. So r over x would be that over that, which simplifies to -1. Got to simplify your answers. Got to know the coordinates for these really, really, really nice angles. And you got to know the definitions. Oh my goodness. Number 3. So they give you this, and you got to find the other 4. So I can think of at least two ways to get tangent if they give you what they're giving you, sine and cosine. Here's one way. Again, you don't have to do my way all the time. I mean, if you got your own way or there's a different way you like that I showed you in class, whatever. But in this case, we got the tangent is going to be equal to the sine divided by the cosine. So that's all I'm doing here. Sine divided by cosine. And I hope at this point that you know that to do a fraction divided by a fraction, or more specifically, in order to just divide by a fraction, you instead multiply by its reciprocal. And so when you do this math, it simplifies to, I mean, in my mind, the 3's cancel out, and you use 1 over root 7. And so there's the final answer for tangent. And again, you don't need for me to rationalize the denominator, since you don't have to do it on the AP exams. But and then to get the other 3, you just use the reciprocals. So you probably are going to need to know this, that to get cotangent, you just flip the tangent. Okay, and I don't want to see root 7 over 1. I want simplified answers, people. To get the secant, you're going to flip the cosine. And of course, to get the cosecant, you're going to flip sine. And again, I don't want to see 3 over 1. I want simplified answers. Number 4, if they give you, for example, that the sine is 1 over 4, okay, and they tell you this, which is information that helps you figure out what quadrant you're in, or if x is positive or negative, and if sine is positive, whatever. Okay, but by telling you this, looks like we are definitely in quadrant 2. Why does that matter? We'll get to that in a second. But essentially, they just want the cosine of theta. Now, the cosine of theta, you should know, like that, is x over r. Again, if you don't know that, you're screwed. Okay, so when they're telling you that the sine is 1 over 4, aren't they really telling you that the y value is 1, positive 1, and the r value is positive 4? Remember, your radius is always positive. So r is positive 4, which makes y positive 1. Well, what else do we need? Don't we need x? We need x if we're going to give cosine. So knowing y and r, how do we get x? You better know that the Pythagorean theorem is what you got to do. So you go with the Pythagorean theorem to end up getting x. And remember that technically, when you end up taking the square root of both sides, it's plus or minus root 15, plus or minus. Which one is it? Is our x positive root 15 or is it negative root 15? That's where this extra tidbit of info comes into play. The fact that it's pretty much telling you that theta is in quadrant 2. So what does that mean about x? Quadrant 2 means x is negative. So now that we know that x is negative root 15, we can give the cosine as our x over r. And so bam, x over r, negative root 15 over 4. Similarly, if they say that here's some point which corresponds with theta, they're giving you x and y. And they want all 6. So if they give you x and y, what else do you need? You need r, of course. And how do you find r? Because it's not necessarily 1. This point is definitely not on the unit circle. So how do we do it? Well, again, Pythagorean theorem. You better know that. And you better know how to properly execute and have this play out, especially when it comes to doing negative 3 squared. In other words, x squared. It's negative 3 times negative 3, which is positive 9, people. And so as this plays out, again, technically it would be like plus or minus when you do the square root of both sides. It's going to be plus or minus, but it's the radius. In context, this is the radius, and so it's positive root 34. And so bottom line, x is this, y is this, and r is this. And that's all you need to know to get the sine being y over r, cosine being x over r, better know that. Tangent being y over x, better know that. And then, again, a lot of reoccurring themes here. To get the other 3, you can just flip the proper other ones. So cotangent, you flip tangent. To get this one, you flip cosine. To get this one, you flip sine. And one final note, root 34, if it needed to be simplified, then you better simplify it for the full points. But root 34 cannot be simplified, so you just don't do anything. But if this was like root 8, for example, you would have needed to simplify that square root in your final answers. Another one like this, man. When they give you tangent, they're essentially giving you y and x, but now it's not so clear at first if y is going to be positive root 2 or negative root 2, and if x is going to be it matters. I mean, yeah, it definitely matters, but it's only one of these, right? Like, so which one of these, y or x, gets the negative? That's where this other piece of info comes into play. And if cosine is essentially positive, that means x is positive. Like, the bottom line for me, anyway, is that x is going to be positive. And if it helps, but we're essentially in quadrant 4. But the bottom line for me is that when it says this, to me that means that x is positive, and so this 5 is positive, which makes root 2 negative. And once again, if we're going to figure out sine and secant and everything, we need r. And so once again, Pythagorean theorem, just you need to know how to play this out, okay? X squared plus y squared equals r squared. Make sure you're squaring this properly to get positive 2. And as this plays out, oh, what happened here? Was this a mistake or r squared? maybe someone's going to catch that in class. That'll be a bonus point, maybe. Or did I? Maybe something happened when I. No, this looks like a mistake on my part. So because that needs to be r squared, because when you take the square root of both sides, technically you get plus or minus, but this is a radius, so it's positive. But guess what? This square root can be simplified. Now, I don't know if you do it my way or another way. The bottom line is, when you simplify the square root of 27, you get 3 root 3. And so now that you know x, y, and r, nothing's really stopping you anymore from identifying sine as y over r and secant as r over x, since secant is the flip of cosine. Moving on. Now we got to do the cosine, sine, tangent, whatever, of these such angles, okay? Now for these angles, you always start with a picture of a triangle. So for 30 degrees, I'm going to draw this triangle for 30 degrees in the XY plane. And you're always going to draw the triangle to the nearest x-axis. And then you have to identify what special triangle it is. And obviously for 30 degrees, this is obviously going to be a 30, 60, 90. And something else you have to know for this test, as far as memorizing goes, you need to know how to label the sides of a 30, 60, 90, which is 1, 2, square root of 3. So you have to know that across from the 30-degree angle is the 1, the hypotenuse is 2, and across from the 60 degrees is root 3. Now you might also have to notice if any of these need to be positive or negative, right? I mean, not so much here. And once you have these sides labeled, now you can use your SOHCAHTOA definitions. So for cosine, your SOHCAHTOA definition is adjacent over hypotenuse. So from the reference angle of 30, the adjacent leg is the root 3, and the hypotenuse is 2. All right? Next one is, I want you to work with 225, which is over here in quadrant 3. Okay? And for 225, this all-important reference angle is going to be 45. And so that makes this a very special 45, 45, 90. You also have to know how to label the sides for this one, which is 1, 1, root 2. Or in quadrant 3, right, we have basically like going in the negative x direction, so negative 1, and the negative y direction, and so a negative 1 over here in quadrant 3. Look, the bottom line is the sine of an angle that's in quadrant 3 needs to end up being negative, okay? So whether you go ahead and label the sides positive or negative correctly, or you just remember that at the end of the day your final answer needs to be negative, whatever. But again, SOHCAHTOA, so for SOHCAHTOA the sine is opposite over hypotenuse, and so again, going with the reference angle, the opposite for me would be negative 1, hypotenuse is root 2, and so there we go. Tangent of this, which if you plug in 180 for pi to convert it to degrees, so you can more easily work with it, it's really the tangent of 120. So we draw the triangle for 120 over here in quadrant 2. You got to go to the nearest x-axis, and you got to know how to figure out what the reference angle is. In this case, it's 60. And so it's another special right triangle, a 30, 60, 90. And so labeling the triangle correctly, you get 1 or negative 1 because it's going right in the negative x direction. 1, 2, root 3. And then you can go with SOHCAHTOA. So tangent would be from the reference angle opposite over adjacent. And so it'd be like positive root 3 over negative 1, which just simplifies to this. Now, again, if you just want to label these all positive, as long as you remember that for your final answer, the tangent of something in quadrant 2 needs to be negative, whatever. But the bottom line is your final answer needs to be negative root 3. Number 8, I just want you to find the value of b. So they give you an angle, they give you this side, and they want you to find this other side. And so the first thing you got to do is write out like a trig equation. Now, if what you're working with is, as far as the 44 degrees is concerned, aren't you working with the opposite leg and the adjacent leg? So wouldn't that be perfect for tangent? Since you're working with opposite over adjacent. So kind of using SOHCAHTOA, you write out the equation of the tangent of 44 would equal 23 over b. And now all you got to do is solve for b. And I'll just point out that since your variable is in the denominator, that might require like an extra step to solve for b. Like I multiply the b to the other side and then divide by the tangent of 44. You can think of this as cross-multiplying, whatever. The bottom line is you should be able to solve for b now. And try not to approximate until the way end. And just doing 23 divided by the tangent of 44 on your calculator. And always remember to approximate to 3 decimal places. And you should be getting that. Same way to start here. But now we got to find the angle. But it looks like we're involving, as far as this angle goes, the adjacent leg. And they're giving us the hypotenuse. So if we're working with the adjacent and the hypotenuse, that to me is which trig function? Cosine. So cosine of the angle is going to be, as far as, again, SOHCAHTOA, the adjacent leg over the hypotenuse. And so that's the setup. And now you have to remember for this problem that in order to solve for the angle, you got to do the inverse cosine. Okay, so you do the inverse cosine of the answer on your calculator, and just make sure you plug it in correctly. This would be like the second cosine, as far as pushing your buttons on your calculator. And so to do the inverse cosine of that, and then round to 3 places, make sure your calculator's in degree mode if you're going to give an answer in degrees. And that's all there is to that one. Now for number 10, you're going to need to, for just number 10, it's going to be the exact same question on the test. All I want is like the basic sketch of sine of x, cosine of x, and tangent of x. And I want you to label it like so, and I want you to be able to identify what the amplitude and period is for these 3. So this is your basic sine of x sketch, and the amplitude is 1. And the period is 2 pi. You should know those basics. And how the sine of x looks, like so. Cosine looks like so. You should be aware of this for more than just these problems. And the amplitude you should know for cosine is 1, and the period is 2 pi. And for tangent, changes a little bit. And I want you to know that there's vertical asymptotes right here at pi over 2 and right here at negative pi over 2, because all I want to do is draw one period, right? Kind of like cosine and sine. All I want to do is draw one period only. And you should know how the basic sketch of tangent. And you should know that the amplitude, it's not really a thing, so not applicable. And you should know that the period is pi now, okay? It's a different period than sine and cosine. Last couple problems. Some graphs. Remember, the basic routine is to figure out the amplitude, and remember, like, your default amplitude is 1, and there's a default period and everything, but, for these guys, you're going to have to basically find the amplitude, the period, if there was a phase shift, or what the phase shift is, and whether or not you're going to flip them or not. And you need to know, just like back here, you need to know like your basic shapes of sine and cosine. So anyway, you're going to have to know how to identify amplitude and period and phase shift. You're going to have to memorize this stuff, okay? So, in these examples, I went through the motions of identifying that our A value is 3, our B value is right here in front of the x is 1/2, and our C value is supposed to come after here, but really there is none, so our C value is 0. And you should realize how to figure out amplitude as the absolute value of our A value, and so just 3. You should know by heart that our period is calculated by doing 2 pi divided by our B value. Okay? And you should definitely know how to divide by a fraction and end up getting 4 pi for our period. And our phase shift is always our C value divided by our B value. You should know that. And so our phase shift or starting point is 0. So starting point of 0, our period length was 4 pi, and then you got to know to divide, at least if you're doing it my way, you got to know to divide your entire period into like 4 sections, and the graphs I'm giving you are already like divided up into like eighths of pi, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4, it's so on and so forth. Anyway, but in this example, dividing up this period into fourths is not that difficult. Here's the halfway point, and then you cut the halves into half, and okay, so you get like fourths. And you got to remember that for cosine, the start of the period is at its peak, which is where the amplitude comes into play. The 1/4 mark is where it crosses. The halfway point is where the cosine bottoms out, because we're not flipping this, right? Again, the A value was positive 3, so we're not flipping this cosine. And so we start at the peak, cross, bottom out. At the 3/4 mark, we cross. And at the end, we peak. And so this is the basic sketch of one period of this cosine graph for this equation, okay? Last problem, same deal, except this is going to be a sine curve. So it's going to go through a different song and dance, right? But our A value is going to be out in front as positive 1. Our B value looks to be 2. And our C value looks to be 2 pi, right here. And so our amplitude is going to be 1. Our period is going to be 2 pi over B, and therefore pi. Our phase shift is going to be C over B. And so that just becomes pi. And so that means our phase shift, which is also like our starting point, is going to be right there. And our ending point, again, is always like our starting point plus our period. And so our ending point is going to be at 2 pi. So you put that together. If our starting point is pi, or if we're shifting to pi, and our period length is pi, then we're going to be ending at pi. And so putting this all together, we're going to be dividing our period into like 4 sections, because those are like the 4 key checkpoints for me. So that's going to be like our halfway point, and then cut the halves in half. So here's our fourths, okay? And remember, you got to know that our sine curve starts at the middle, and then at the 1/4 mark it peaks. Again, that's where our amplitude comes into play. At the halfway point, we're crossing. At the 3/4 mark, we're bottoming out at the low point. And at the end of the period, we're back up at the middle. So there it is. There's one period for this graph. And that's it.